All right, in this video, we are going to work through the following example. It says if the sine of theta is equal to negative 7/25 and theta is in quadrant 4, then what is the value of the cosine of theta over 2? All right, so we need to figure out what the value for cosine of theta over 2 is. And so if you look at that, you can see that is a half angle. Inside the parentheses, I have something divided by 2, right? In this case, theta divided by 2. If I look at the identities, right, that's going to be a half angle identity. So it's this half angle identity right here is the one that we can use. So I'm going to write that down. So cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta quantity divided by 2, like so. Okay, and so in order to use this identity, we need to know the cosine of theta, but we are only given the sine of theta, right? So what that means is that we'll have to do some extra work over here. We know that the cosine squared of theta plus sine squared theta is equal to 1, right? And we know that the sine is negative 7/25. All right, and then we can solve for cosine. So that'd be 49 over 625. When we square that out, and then we would subtract 49 625s. From both sides. Over on the left side, we would get cosine squared theta equals. All right, and then 1 minus 49 625s, we would have to get a common denominator, which is going to be 625. And so 1 would be 625s over 625, right? And then subtracting 625 minus 49 is 576, I believe, over 625. All right, and then the cosine of theta would be plus or minus square root of 576 over 625. And both of those are perfect squares, right? Square root of 576 would be 24. And the square root of 625 is 25. So we have now the cosine of theta. And what we'll need to do is to figure out which one we should choose, right? The positive one or the negative one. And of course we do that by just thinking of the quadrant in which this angle is located. So here's the unit circle, and they tell us that theta is a quadrant 4 angle, right? So in standard position, the angle is going to look like this, and that means that the terminal side of this angle intersects the unit circle at a point down here in the 4th quadrant. And down in the 4th quadrant, the points have positive first coordinates and negative second coordinates, right? Like so. And so since the cosine is the first coordinate, right, this cosine has to be the positive version. So the cosine of theta equals 24 over 25, 24 25ths. Okay? Okay, so now that I finally have this value, I'm going to put it back up here into this identity. So cosine of theta over 2 is either equal to plus or minus the square root of 1 plus 24 25ths over 2. And I'm going to have to work that out, okay? All right, so cosine of theta over 2. I want to simplify that as much as possible. So I need to get rid of this complex fraction that's underneath the radical. So what I want to do is add these two fractions, 1 plus 24 25ths. Of course, I need a common denominator to do that. So I write 1 as 25 25ths. And so I go ahead and add, now that they have a common denominator, that's going to come out to be 49 25ths. And I made that too small. Like so. All right. So now I am dividing underneath the radical. I have 49 25ths, and I'm dividing that by 2, right? Remember, I can write 2 as a fraction, and when you divide by a fraction, that's the same as multiplying by the reciprocal. So dividing by 2 over 1 is the same as multiplying by 1/2. All right, and when I multiply that out, I get 49 over 50. All right, just multiplying across the top, 49 times 1, and multiplying across the bottom, 50. All right, next up, I want to simplify that as much as I can. So that would be square root 49 over square root 50. (49) is a perfect square, right? So I can write that as 7. 50 is not a perfect square, right? But I can write it as 25 times 2. 25 is the largest perfect square that goes into 50 evenly. And that would be 7 over square root 25 times square root 2. The square root of 25 is 5, right? And then finally, to reduce it down and get that radical out of the bottom, I would go ahead and rationalize by multiplying top and bottom by square root 2. On top, I get 7 square roots of 2. On the bottom, I get 5 square roots of 2 times square roots of 2, which is 5 times 2. I'm going to erase some of this because it's getting kind of crowded. So I get plus or minus. I'm going to have to go up here. Not enough room. So I get plus or minus 7 square roots of 2 over 10. Okay? So now what we need to do is to decide whether or not it should be the positive solution or the negative solution. So one thing that piece of information that they give you, right, is that they say that theta is in quadrant 4. Okay? And it actually turns out that that really is not enough to nail this problem down. I don't want to go into the details of it, but really what they should be saying is that theta is either greater than 270 and also less than 360, or saying that in radians, however you want to do it. So in other words, if I look at the unit circle, that quadrant 4 is down here, and I know that the terminal side is somewhere down there in quadrant 4. Saying theta is in quadrant 4, though, doesn't really, like I said, it doesn't give you enough information as to which one to choose here. So what you've got to do, and they should, correct this, is nail down the range a lot more. They should be specific and say that theta is in between 270 and 360, or 3 pi over 2 and 2 pi in radians. Okay, so when you work these problems, you're just going to have to make that mental adjustment here. And now this is not always true for a quadrant 4 angle, but that's looking at the answers on our homework system. It seems to me like this is the assumption that they are making. Okay, so if they say it's in quadrant 1, then you should go between 0 and 90, or 0 and pi over 2 in radians. If it's in quadrant 2, then between 90 and 180, and in quadrant 3 between 180 and 270. So they really should rewrite these problems to be more specific. Otherwise, there's no solid choice here. Okay, so what you want to do is, now that we know that theta, what they're really trying to say here, theta is in between 270 and 360, then divide all of those by 2. And 270 divided by 2 is 135. 360 divided by 2 is 180. So we have to pick, one of these plus or minus for cosine of theta over 2. So now we know pretty much exactly where theta over 2 is located. Theta over 2, right, is in between 135. So if you look where 135 is up here, and then 180 is right there. So we know that the terminal side for theta over 2 is up here in quadrant 2. So that's what this means, okay? So now we know theta over 2 is in quadrant 2, all right? So in quadrant 2, right, we know that the points up there have negative first coordinates and positive second coordinates. And since the cosine, right, is going to be a negative up there, then that means that the cosine of theta over 2 has to be a negative number. So that is going to allow us to nail that down and say that it is minus 7 square roots of 2 over 10 as the final answer here. So again, the problem as it was posed here, and this problem is from our homework system, that theta is in quadrant 4, that's not enough information to be able to pick the positive or negative 100% of the time. It needs to be nailed down more like what I have here, and I think that is what they meant to do. They just didn't do it. So when you are working these problems, with these half angle problems, you're going to have to make this translation. If they say theta is in quadrant 1, then put it's between 0 and 90. In quadrant 2, between 90 and 180. Quadrant 3, between 180 and 270. Quadrant 4, between 270 and 360. And then divide through by 2. That will allow you to nail down the specific quadrant that theta over 2 is located in. And once you know what quadrant theta over 2 is located in, then it's easy to pick the plus or minus by looking at the signs of the points in that quadrant. All right, and so that is it on this one.